The experiment focuses on programming a C code for a PIC16F1887 microcontroller to generate delays for LEDs using delay polling and
Oo,
interrupt.
picket yung ginamit.
Polling involves checking the status of a condition in the microcontroller's registers. It's configured to generate interrupts when a specific time interval elapses. The main program continuously checks this timer zero where it delays its execution until the timer reaches the desired interval. However, simple polling based delays may negatively affect the processor,
Oo,
which makes it
picket
less
yung
suitable for
ginamit.
multitasking. Timer 0 can be configured to generate interrupts, which triggers a dedicated interrupt service routine or ISR when the timer overflows. The main
Oo.
program can continue its execution, and while or when the ISR is invoked, it will perform the necessary actions to signal the completion of the delay. Interrupt
Oo,
based
picket
delays
yung
are suitable
ginamit.
applications for multitasking functions. The first code used in the main.c file utilizes delay polling. It was observed that the LED switches between on and off at a time interval of 250 milliseconds. This is due to the timer 0 peripheral where it sets the time LED, where the clock prescaler states the maximum time of the switching. The if timer 0 underscore has overflow occurred is a statement checking whether an overflow occurred in timer 0. Timer overflow happens when the timer reaches its maximum value and wraps around to 0. Lastly, TMR0 if clears the timer 0 over flag, which is necessary to acknowledge that the overflow has been handled, because if it's not acknowledged, the program will keep entering the statement. This second code used in the main C file also used delay polling. It was observed that LED switches between on and off at a time interval of 2000 milliseconds or 2 seconds. The main difference is that the clock prescaler states the maximum time of the switching, which is 1 is to 200, 2048. Aside from that, all the other codes are the same. For this code, used in C file, it used the interrupt instead of delay polling. The difference between delay polling and interrupt is that interrupt set up timer 0 peripheral to generate the periodic interrupts. When an interrupt occurs, the microcontroller executes a specific function, which is ISR, to handle the event. However, delay polling uses a loop to wait for a certain amount of time, which is during this amount of time, the microcontroller is often busy doing nothing. The global interrupt enable and the peripheral interrupt enable functions at the main C file enables all interrupts globally and peripheral interrupts respectively. Timer 0 checks if a function pointer is not null. It's allowing users to define their function to be executed when the timer 0 occurs. This can change the behavior of the program when the timer 0 interrupt occurs. And D5 underscore LED underscore toggle is the state of the D5 LED. This one uses the same code in the main C file. Like delay polling, it was observed that the LED switches between on and off at a time interval of 2000 milliseconds or 2 seconds, where it also has the same settings as the first code except for the timer having a clock prescaler of 1 is to 2048. For our first experimental setup, it involved an LED connected to pin RA7 of a microcontroller, which is powered via VDD and VSS connections. We had the intention of creating a delay worth 250 milliseconds, and it relied on the delay polling and interrupts that was coded earlier.
Kailan sunod nung klase?
This experimental setup involved the same connections during the past attempt, but this time we had the intention of
Wala
creating
naman
a
sinabing
2000
ano kasi
millisecond
sa
delay,
experimento.
which is why you can see that the LED blinks every 2 seconds only.
Ano ba nakalagay sa
This experimental setup to investigate LED control utilizing the delay polling and timer zero interrupts, we constructed this microcontroller circuit. The LED blinked at intervals of 250, 2000, and this time 5000 milliseconds due to delay polling. We suggest using different pins for different code versions, double checking the pick it connections, and using templates to uncover issues and choosing the right version of the MPLAB IPE and IDE to ensure smooth running, compiling of the codes. Thank you very much for listening. This is our report for Experiment 3 for digital electronics.